Yeah, good morning dear students. Today we are going to discuss the topic on spectroscopy. Particularly we are going to discuss about UV visible spectroscopy. What is the meaning of spectroscopy? Spectroscopy is the measurement and the interpretation of electromagnetic radiations absorbed or emitted when a molecule or a compound or ion move from one state to another state. What is the meaning of this thing? Particularly we are going to measure and interpret both the electromagnetic radiations. Electromagnetic radiations are a broad range of radiations because whenever the molecule moves from one state to another state, say maybe from ground state to excited state, they will undergo the absorption of radiation, and when the molecule comes back from excited state to ground state, they will emit the radiation. So either absorption or emission of radiation taking place, and this is concerned with the spectroscopical aspect, and particularly what is called EMR, electromagnetic radiations, are the discrete particles. These are the discrete particles called photons, which is having both the particle characteristics as well as the wave characteristics. So when I want to discuss about this electromagnetic radiation, there are different classes of electromagnetic radiations in nature. So starting from cosmic rays, gamma rays, X-rays, UV radiations, visible radiations, infrared radiations, microwaves and radio waves. These are the various types of electromagnetic radiations based upon the wavelength range. For example, if I want to discuss this electromagnetic radiation, the wavelength range will be starting from 10 power minus 12 meter to 10 power minus 1 meter. So when I talk about 10 power minus 12 meter, here we are having the cosmic rays, and after that we will be having the gamma rays. So gamma rays, after gamma rays are having the high penetrating power, you know that energy is very high, and after that we will be having X-rays. The X radiations are having the higher energy and they have the lower wavelength, but these X radiations, the major mechanism of X radiations involved in spectroscopy is bond breaking and ionization of the molecule. After X radiations, we are having UV radiations and followed by visible radiations. So this UV radiation and visible radiation, preferably if I want to talk about this UV visible radiations, UV radiations are having the major principle of electronic transition. So whenever the energy, you know the very important concept, energy is inversely proportional to wavelength. So whenever the energy is very high, wavelength will be lower. So when I show these type of electromagnetic radiations in the range, so in this corner they have the high energies whereas they have the lower wavelength, right? Whereas if you go for this UV radiations and visible radiations, they are also having the higher energy. So when I talk about the UV radiations which is having the higher energy, these UV radiations undergo the electronic excitation process in which the molecule will be moving from one state to another state, particularly from ground state to excited state. So why I am talking about this UV radiations? Because our concerned topic is UV visible spectroscopy. So when I want to talk about this UV visible spectroscopy, you should remember one important aspect. Any molecule, because they have the higher energy, the molecule will go for initial rotation followed by vibration and followed by electronic excitation. So because they have the very higher energy as such. So whenever we go for this molecule, they will initially undergo the rotation followed by vibration and followed by complete electronic excitation, where the molecule will jump from ground state to the excited state. So here, when the radiation, whenever these electromagnetic radiations after UV radiation, visible radiation comes with the infrared radiation. When I go for infrared radiation, the energy is little get lowered. So in infrared radiation, what will happen? Preferably in infrared radiation, you don't have that much of energy as compared in UV visible radiation. So here what will happen? The molecule will go for rotation and followed by vibration. Because they don't have that much of higher energy, so they will only go for rotation followed by complete vibration. So the vibration of the molecule is concerned with stretching and bending vibration. And after IR, that is after IR radiation, we will be having microwaves and radio waves. So what is this microwaves and radio waves? Microwaves and radio waves, they have the very low energy, but they have the very high wavelength. What is the reason? Because whenever a person is traveling in submarine, and if you want to connect the person who is traveling in the submarine from any corner in the world, you must have a longer wavelength. Definitely there we are using the radio waves as such. So radio waves and microwaves are having the longer wavelength, but energy is very, very less. And in this concept of microwaves and radio waves, as the energy is very low, it is very, very difficult to measure the radiation, the amount of radiation whenever it is getting absorbed or emitted when they move from ground state to excited state. It is very, very difficult because the energy for absorption is very, very less. So what will happen if you want to measure because as I told in spectroscopy, the basic principle is measurement and interpretation of electromagnetic radiation either absorbed or emitted when a molecule or atom or ion moves from one state to another state. So that is the reason in case of microwaves and radio waves, what we are generally doing, these microwaves and radio waves, preferably whenever we are analyzing the radiation, because their energy level is very, very low. So what we have to do, if you want to measure the microwave impact on the molecule moving from one state to another state, you must apply the magnetic field. The similar case with radio waves also. Only in the presence of magnetic field, these microwaves and radio waves will try to get absorbed by the molecule, and the molecule will slightly get flipped up to the excited state. That means they have a minute rotation. They don't have vibration, they don't have electronic excitation. So, as I told very clearly, in case of UV radiations and visible radiations, there is a electronic excitation. How this electronic excitation takes place? Because the higher energy is absorbed by these radiations. So, what will happen? Initially, they will go for rotation, followed by vibration of the molecule, followed by complete electronic transition or excitation of the molecule. Whereas in case of IR radiation, the energy is lesser, so what will happen? They will go for rotation and complete vibration of the molecule. Whereas in case of microwaves and radio waves, their energy is very, very low, so what will happen? They are having enough, they don't have that much of capacity to vibrate or electronically excite, but they just affect the rotation of the molecule. Therefore, microwaves and radio waves, that too we can analyze these rotations and the flipping of the state from one state to another state in the molecule, we can concerned only with magnetic field. So without magnetic field, it is very, very difficult to measure the impact of microwaves upon the molecule for getting absorption. So this is the reason we are using the magnetic field, and these microwaves, particularly in the presence of magnetic field, the phenomena is called electron spin resonance. Whereas in case of radio waves, the phenomena is called the presence of the molecule with the help of impact of radio waves, absorption of radio waves by the nucleus of the magnetic field. So when we are using this radio waves concept, then the technique is called NMR or nuclear magnetic resonance spectroscopy, because the energy is very, very less. Therefore, the molecule moves from one state, that is the nucleus moves from ground state to excited state. It is a very minute distance. Therefore, we call them as NMR, nuclear magnetic resonance spectroscopy. So this is all about the various things in spectroscopy. So what is spectroscopy? Spectroscopy is the measurement and the interpretation of electromagnetic radiations either absorbed or emitted when a molecule moves from one state to another state. Either maybe from ground state to excited state or from excited state to ground state. Thank you very much.